So this is a random attention model, an alternative for random utility or random parameters model. So let's start with some pictures. I mean, I'm not going to go over this, but this is actually strikes me most. These are toilets, and if you go to, I went to Lowe's. This is one of the home improvement stores in the United States, and do you know how many toilets you can buy? More than 700, and as little as costs $80 to $5,000. So I didn't know this, but the point is there are too many choices, and I guess we got that idea. Then limited attention is just the implication of this. People do not pay attention to all the products. That's what I would like to claim, and that could be different reasons. It could be information overload, unawareness, maybe more, or both, or many other reasons. Actually, much before us, much before the economists, marketing guys and the psychologists actually aware of this. Much before us, it's starting late 1960s. They even coined a term called the consolidation set for that purpose. And what consolidation set means is the set that made of the products that consumers taken seriously when they make a purchase decision. Let me highlight here consolidation set. Either you belong to consolidation set or not. So the guy or consumer basically neglect object. There are other way of approaching this problem. Maybe there are attributes, and some people erase the attributes. That's not what the consolidation says about. It's about you ignore the alternative. So if you have a consolidation set, then there is a kind of a two-stage procedure that consumer follows. So this is the choice set that's available. For example, you want to buy a toilet, and you go to the Google and you search. And what you do, you only consider the first page in the Google search. Okay? Once you have this, then you maximize. You have a preference when you compare those things, and you choose the maximum one. Okay? So far, so good. This is a very simple model. Actually, if you're the decision theorist, and if you ever have a chance to talk to psychologists, they start laughing. And the first question they say, do you believe revealed preference? Of course, I might say yes. And they say, okay, what about the consolidation set? Even though a consumer chooses X when Y is available, how can you say X is better than Y? And that's actually the first thing they tell you. And as a decision theorist, I used to say, I don't know. We haven't covered that yet, and blah, blah. So recently, myself, and two of my co-authors tried to answer that question, okay? And many others actually work on this too. And we say that you can do revealed preferences, okay? It's fine, but I'm not going to talk about that paper. What I would like to do today is, in that model, consolidation set is deterministic. For example, always you go to the Google page and you look at the first page. Or you go to the supermarkets, you want to choose a cereal, you go to certain part of the the supermarket, the shelf, and you always do this exactly the same thing. In reality, maybe one time you do the Google search, the other time you do the Yahoo search. Or in the supermarket, one time you get in the aisle on the left, the other one on the right. And in those cases, you might end up different consolidation set. So what I would like to, so that's the one reason that I want to make the models more realistic in a sense. And also I want to write a new model or new paper. And the other reason that I think more important, when you talk to also econometricians, and if you give them a deterministic model, they say, look, I cannot do anything with this. And that's the reason that I would like to give a model where it's a random attention in it. Hence, the model that I'm going to talk about is exactly like this. Now, you have a choice set, and there, you might end up with the different consideration set with, certain probabilities. Again, you are going to, once you decided the consideration set, you are going to maximize over this set. Okay, so this is the model that I'm going to talk about today. The assumption, consumers is able to rank options. So that's the utility maximization. Consumer chooses the best option within their awareness, within their consideration set. And in this model, randomness is going to come from the random consideration. The random utility model is alternative of this. Random utility model, you have the choice set is fixed, but you might have a different utility function, different arrows like this. Okay? I'm going to tell you what are the differences, but at least I can do reveal preference here because there is only one preference that I need to pin down. In the random utility model, I don't know which one is the utility function. We have no clue on that. So that's why, I would like to do this. So I hope you will remember this picture. If you don't remember anything else, that's what the model does. So domain, actually, this is the trick that decision theories use. We use it, domain so, reach that everything actually works. In this case, actually, no, I'm going to use the finite model, and I'm going to talk about the abstract. So there is no structure on the domain that I'm inducing, so that the model actually can be applied to voting, applied to consumer choice. It could be applied to lottery choices or anything else. The data actually, let me go. So here the observables are, what is the choice set? Like all the products in the supermarket, and what the guy chooses. So everything in this, the gray or the green, is supposed to be green. All these things are unobservables. As an analyst, I don't observe those things. These are in the mind of the decision maker. The only thing that I observe those blues. Okay? And here, consideration set is probabilistic, hence the choice is probabilistic. Okay? And this object is going to tell me what is the probability X being chosen when this guy is facing S as a budget set. And I'm going to assume standard assumptions on this. It needs to be positive, and it needs to be add up to 1. When I look at all the probabilities, it needs to add up to 1. So now let me talk about the unobservables. That guy was observable. So now I have a consideration set, and I use this notation to illustrate what is the frequency each consideration set happens, considering D when the feasible set is S. Okay?
So the decision maker is not active, right, in taking the different consideration sets?
I don't know. As of now, I'm not making any assumption. All I'm saying is he's doing this, maybe purposely, or maybe,
This is not relevant, okay.
It might be relevant, but as of now, I'm not going to make any assumption on this. Again, this is needs to be probabilistic. For each S, for all subset, this needs to be positive, and they need to add up to 1. Okay? So nothing. So let me tell you what are the, what type of things you might see. So this is S. So this is the budget set. In this budget set, there are 7 subset or 7 consideration set might happen. And the property says that those numbers needs to be either between 0 and 1, including 0 and 1. And for each row, it needs to add up to 1. The full attention, you always consider what is available. So it needs to be 1, all this diagonal. Okay? So that's the standard model. This is what we do. When we teach, the grad student, that's what we do. We said, okay, people pay attention to. Whenever we give them, that's how we do the revealed preference. Let's relax. Still deterministic. Deterministic in the sense that you only have one consideration set, but it is not full attention. For example, here he considered only xy. For yz, he only considered singleton y. So this is another my stochastic consideration set, and this is actually non-deterministic. Now this guy can be actually think about different subset with different probabilities. or here, or here. Okay? So these are the objects. So my model is as simple as before. I'm going to say that the probability of x being chosen, it depends all the consideration sets where x is the best. If you sum them up, you get what is the probability you have. Okay? So that's the model. These are observable and these are unobservables. I think we are happy to make this assumption on the preferences. We said this guy actually can compare any two alternatives. So now, question mark comes here. What is the property that I'm going to induce on this attention sets? First thing that you realize, if you do not put any condition on this, any choice behavior can be rationalizable. How? Tell me what is the probability x is chosen. I'm going to go look at the singleton x at that time, guy, and plug that number there, everything goes through. So that's, but you don't want that theory because that theory is an empty theory because it explains everything. So far I'm not doing a good job, okay? So then I need to put something here. So here actually you need to make a choice. Why? For example, I can assume full attention. I can put the full attention here. I'm going to go back to Samuelson. But that's not good because we know the Samuelson model actually violated many, many times. On top of it, what I am interested here, I would like to identify this revealed preference. Okay? So when the psychologist friend of mine came to me and he said, okay, can you say x is better than y? That's what I want. Then this means that the stronger condition I put here, of course I will make a more prediction. That's exactly the full attention. The other way, I can actually assume certain formation of A. For example, the Google search that I described. But how do I know that this guy is following the Google search? Maybe he's asking someone else. So I want the model to apply many, many different consideration set formation. For that reason, I'm going to just induce very weak property. Okay? Again, my aim is identification. If you want your model has a more predictive power, then put more conditions on it. But as of now, for today, my aim is to do reveal preference so that I'm going to try to induce as little as possible. And I'm going to convince my psychologist friend that, look, you can still do it. For that reason, I have no clue, but I can go to our old paper. Even though they work with the deterministic, they actually follow the same idea. And they say, OK, let's put a simple condition. And the condition that they put says that, look, if there is a product that you do not pay attention, this is actually their notation, how represent the consideration set. If there is a product that you do not pay attention, this is the Google search, a product that in the 10th pages. What happens if I remove that product? What happened to this guy's formation? It says it shouldn't change. If you're unaware of something, then you shouldn't be aware of it either. Okay? The problem is, this is an object between a subset to subsets. It takes one subset and brings it to another subset. But this is the one that I have is actually just a probable, between 0 and 1. So there is not really connection, at least I couldn't see for a while. This takes like 3 years to see it. Maybe it explains something about me rather than the difficulty of the problem. OK, let me try to see. Assume that your consideration set when everything is available on x and y. Let me translate this into my world. This new world. This means that from x, y, z, there is only one. This is x, y, and you pay attention fully. You are not paying attention to z. What it means, if I remove z, nothing should change. You should still pay attention to x, y. Let me write that rule too. So this condition says if this is 1, this needs to be 1. So this means that relative attraction of that consideration set, if you remove some alternative, should not decrease. And also notice that there are more consideration sets with more alternative. So eventually those weights, if there are any weights here, they need to distribute to the rest. Hence, that's the condition. If there is an alternative that you do not consider, then the attractiveness of this consideration set should not decrease with a lesser alternatives. Okay? It's very weak. And I'm going to actually show that there are actually many formations that satisfy this property. And I'm going to try to work out whether this will reveal anything for me. Okay, so the model, random attention model, RAM, is exactly this. I'm just sticking property A here. This is weak. Maybe I don't have any prediction power. I impose something, but maybe it's actually still is so general model. Actually, no. The model can be falsified. Even can be falsified with 3 alternatives. Here's the example. This is the one that's observable. Okay. This is the probabilities. This is the one of the example 3 alternative. This is not a part of the random attention model. I'm not going to explain why, but take my word for it. I just convince you that attention filter Masatlioglu et al. Is actually equal to property A in the deterministic world. Hence, all the examples that they use actually will be applicable here. Actually, they say some of them rational, like the Jose was saying that this guy is actually doing intentionally, but there could be some heuristics so that the model both capture rational and the kind of irrational ones. And any stochastic version of this. Not only those guys, any stochastic version of this. I have 10 minutes. So now there are more. When you open the box, Pandora box, everything pops up. So this is actually a paper by Manzini and Moriotti. Here what they say for each alternative, attractiveness of each alternative measured by this parameter. And then we can actually rewrite what is the probability that you consider xy when that actually given this parameter, you consider x and y with this probability, and this is the calculation. And then if you calculate everything, does this satisfy property A? It was easy to check. Take each column, go down, and everything if increasing, my property A is satisfied. Is increasing. So the property A is satisfied. So their model is a specific consideration set formation, but nevertheless it satisfies my property. Okay? Even it's actually, even much, the richer when this parameter depends on this alternative. It's also satisfy that property. Logit attention. Logit attention is, everyone knows logit, the logit formula where there is a weight for each alternative. Here, there's a weight for each subset. And the way that you pay attention to D is what is the weight for this and for all of them. Okay? And this actually, you can think that psychological strength of that subset, that consideration set. This is one example where weight is number of alternatives in it. And it's going to satisfy Y property. Ordered logit, let me pass this. Elimination by aspect, let me pass this. Okay, what I suggest to you, I'm going to do revealed attention. I'm going to do reveal preference under random attention. That's actually the key. How can I do this? First thing that you need to notice.
Your example, the probability distribution over the consideration sets didn't sum to 1 for a given
it needs
choice.
to be.
But they don't need to, I guess. But
it needs to be.
oh, like for instance.
I made a maybe calculation mistake, but they need to add up to 1.
Yeah, that's what I would have guessed.
Yeah, they should.
So this one is okay, but perhaps I was.
It will. It will adjust it in a way that some. Okay, where I am. So the first thing that notice, there are multiple representations for the same choice behavior. Because the model is rich. In this case, especially if policymaker comes to me and says, can I say X is better than Y? I have multiple representation. Which one is the correct one? In this case, we say, okay, X is revealed to prefer to Y if for each representation, X is ranked above Y. Okay, very, I'm not going to make any mistake, basically. I don't want any mistake when the policymaker asks me. So that's why, that's how I. So actually then what I should do, give me your choice. I'm going to find all the revealed preferences or all the representation, then I can write this one. But that's not, practical. If I'm asking you to do this, then I wouldn't be here. So I'm going to give you a shortcut how you can actually find out this from observed behavior, not using the representation. So first of all, look at this. This is actually a random attention model. And in this model, actually, as you see, the probability of X from here to here goes down. When I remove Y, probability of X goes down. That's actually what people call violation of monotonicity or violation of regularity. And random utility models never predict such a thing. So this basically, the model that I'm giving you completely different than the random, not completely different, is, predicts something different than the random utility models. And this is not random utility models. So the revealed preference. Revealed preference, it turns out that also related to this fact. Whenever you observe such a regularity violation, when you remove Y and probability of X is decreased, in this model it turns out to be X is actually revealed to better than Y. That's necessary. It's not sufficient yet. Okay? This actually is the proof, but I don't have time, I guess. I'm going to skip this. So that's actually the object that I'm going to define. X is revealed to better than Y whenever probability of X is lowered when you remove Y. There must be something between X and Y. My preference is transitive. So then I can actually take the transitive closure of this. If there is an indirect ones, I can actually connect them. And the characterization that we have, if the P have a RAM representation, if the model is correct, then X is revealed to prefer to Y, if and only if that object is true. So this guy is not only necessary, but also sufficient. So in this model, okay? So this is the illustration. Even under very weak assumption, the revealed preference can be done. Okay? Of course, if you want to assume more assumption on the stochastic attention, you can improve this. But I don't want to do this as of now. I want the model apply many wide choices. So that's why. This is the reveal. This is a decision theory paper, but you haven't seen any axioms. I'm going to keep it that way. So this will be your first decision theory paper without an axiom. I mean, of course, in the paper there is, but you cannot, I am a decision theorist, so I need to put some axiom somewhere. So conclusion, it's a very rich framework. I mean, good or bad, depending on what your aim. And it's an alternative to random utility model. Given that Jose says something bad about the random utility model, it's a good time to introduce something new. Revealed preference, what this tells revealed preference is still a powerful tool. You can apply the both rational and bounded rational behavior, both deterministic and stochastic. So we are not, revealed preference, maybe we need to do a different way than we used to, but still is a very strong tool. And now I can actually come and talk to my psychologist and just stand, straight. I guess I should stop.
If there is any question, please take the microphone.
So do you have a sense for the kind of uniqueness? Because you say your psychologist friend has a representation in mind, so now you can say for his representation, X is preferred to Y. But you know something about the class of?
So this is the uniqueness. Because this tells you you cannot learn more than this guy under those assumptions. For example, I can give you the full attention, then you can learn everything. But given that assumption, you can at most learn this. This is surprising.
Yeah, that is.
People are limited attention. They're even stochastic. Like all these things going on, I thought I will never gonna give you anything.
Yeah.
But this says no. There is still a hope for us, and that's actually identifies exactly. There is no. I don't need to see the representation. Everything from the observed choices.
Can you identify the random attention?
Next one.
Yeah.
Next paper. It is not easy. I mean, this is not easy either, but random attention, it gets much more. I'm thinking the fuzzy sets. I need to write those type of stuff, and then it's not easy.
We'll
I have some condition, but I don't want to make a big deal now. But it's a natural question, but I'm far away from telling you any result as of now.
Any other question?
Thank you.